Hello, Algebra 1 students. This is Mrs. Oski back for Chapter 5.0, Part B. Today we are going to be covering the learning target, I can identify the parent functions. So basically these are all the parent functions that you're going to have to learn and be able to match them up for your quizzes and tests. So the first one is called the linear function. This is one that we're very familiar with. We've been working with the linear function, and the basic equation is y equals mx plus b. In last lesson we talked about function notation. You can do f of x equals mx plus b. So all of these, you could replace that y with the f of x to write it in function notation. So let's just go over some characteristics that we know about the linear function. We know that it has a constant rate of change. Constant rate of change or slope. We know that it is a straight line. We've talked a little bit about domain and range, and we'll come back to that and what that looks like when you're reading the graph. So we'll leave that blank for now. So leave yourself someplace. We might come back to that in another lesson. And then the next one is the absolute value. I said a little bit earlier that this is the basic what we're going to be going over, the absolute value function. We're going to be going over that in this chapter. So you need to be very familiar with it. It is a V-shaped graph. That is very important that you know. Just by looking at absolute value, it's going to be the V-shaped graph. And this graph has symmetry. So here's your line of symmetry here, and it's a reflection, symmetrical to either side there. Okay. The basic form of this one is f of x equals absolute value of x. And just a quick review, absolute value means it's the distance from zero. So these bars here stand for absolute value, and we'll look at how to work with that in the calculator and what that means later in the lesson. Back up here, this graph right here is the basic form f of x equals x. That would be the graph of the parent function there. All right, the next one, quadratic. This is f of x equals x squared. So if you see that x squared here, that's your cue. It's going to be a quadratic. A quadratic function makes this U shape. So it has a U-shaped graph. And that U-shaped graph is called a parabola. Okay, that's another term you should be familiar with. And just like the absolute value, this also has the symmetry. Next one, square root. So f of x equals square root of x would be this graph here. And you see that the y values are slowly increasing here. It's slowly increasing upward there. We're not going to spend a whole lot of time on these next ones. The main idea is that you just recognize the name with the equation with the graph. That's what we're concerned about for this lesson. Next one, cubic. cubic. F of x equals x to the third. To the third is also called cubed, x cubed, or x to the third, and that's a cubic polynomial. This also has symmetry about the origin this time. Exponential. This is when the x is the exponent. Your exponent is your variable x there. And this one is interesting. It has an asymptote. Asymptote is this line here that the graph is getting closer and closer and closer to this x-axis, but it never quite touches it. And we'll talk more about those asymptotes later. Next one is the logarithmic function. And there's your graph of that. This also has an asymptote right here. It gets closer and closer, but never quite reaches. And then rational or reciprocal horizontal asymptote there. And so be familiar with all of these. All right. So let's go on. Last lesson, we went over a couple learning targets. The first one was I can graph a function rule using a table. And I challenge you to do page 3. So we're going to go over that right now. Remember the success criteria from before is you're going to take your x values and plug them into your equation. Simplify that, and that gives you your y values. Once you have all the y values, then you can go ahead and graph it. So let's do that. I'm going to show you how to work these in your calculator too. Clear this out. Okay. So if I'm trying to do the absolute value right here, so I have the absolute value of x plus 1. Those bars mean absolute value. And absolute value is always positive. So if you want to just do this in your head, you could. You would plug in that -2 to the absolute value, and you know that the absolute value always returns a positive number. So that becomes +2 plus 1 is 3. But let's look at what that looks like in the calculator. So you're going to go to math, right here, math, over to number, and that first one is the absolute value. I'm going to push enter for that. And now I can find the absolute value of whatever number I want. So I want absolute value of -2 there. So I'm going to type in -2, close up my absolute value with a parenthesis, and then add the 1. Enter, 3, same thing. All right, so let's try another one. Absolute value, go to math, over to number, it's that first one, choose enter, plug in -1, and then add the 1. And you get 2. So on, keep going through. If you plug in 0, you get 1, 2, 3. If you want to go ahead and pause the video and type those into the calculator or work through those on your own, you can. But I'm going to go ahead and graph it. So I'm going to plot all my points. So -2, 3, -1, 2, 1, and so on. And notice that it makes that V shape. This is the absolute value. I know because I see absolute value signs here. This is the absolute value function. Remember what we said earlier, absolute value functions make that V shape. All right, let's try another one. So this one has the x squared in it. That x squared tells me that this is going to be a quadratic. This is going to be a quadratic function. So if you think back to your notes, quadratic functions make that U shape, that parabola. So our graph should end up looking like a U. So let's go through and do this one. So you would plug in that -2. -2 squared, or -2 times -2 is 4. 4 minus 2 is 2. Now let me show you how to do it on the calculator. Okay, so I'm going to take whatever my number is, and I want to put it in parentheses. This is important because if you don't put it in parentheses, it's not going to square that negative. It'll only square the 2. But I want to square -2. So I'm going to put -2 into the parentheses. I can either use this squared button right here, x squared, or I can use my caret and then push 2. Either way works. I'm just going to click that one, easier. And then now I'm going to subtract 2. Enter. Boom. You get a 2. Let's try it again with -1. Remember, put it in parentheses because you want it to square the negative as well as the 1. -1 squared minus 2, -1. All right, you would continue to do that. I'm going to go ahead and save time and just fill it in, but you can pause the video and keep working on your own. Okay, and then we're going to graph it. -2, 2. -1, -1, and so on. And look at there, it makes that U shape. Perfect. Draw that parabola. All right, next one. All right, we're going to take the -2, plug it in. So this one is 4 minus. Remember, if you're squaring, it needs to go in parentheses because you want it to square the negative. So parenthesis, -2 squared, and you get 0. I'll show you one more. 4 minus parenthesis -2 squared. Oh, I did the same one. Whoops. -1 is what we were trying to do. There you go, 3. Also, let me point out the difference between a minus and a negative. So make sure you're not mixing those up. If you do, you might get an error or it might not turn out correctly. Finish this chart up. And then go ahead and graph your points, plot the points. Quadratic makes that parabola, that U shape. And remember, you can tell right away that it's a quadratic because of this x squared. So before you even start, you should see, oh, that's a quadratic. So I know when I graph it, it's going to make that U shape. This one happens to be opening down. And we'll talk about that a little bit later. But why it's opening down is because it's a negative. And we'll go over that more in a later lesson. All right, next one. So you're looking at the formula or the function here. You see absolute value, so I know it's an absolute value function. I know my graph is going to be a V. So go ahead and let me show you what this looks like in the calculator real quick. All right, so that's a -2 times, I don't really need to put the times, I can smush it together in the calculator. Absolute value, go to math, over to number, first one there, enter, stick in your number you need, -2, and there you go, -4 is the answer. Go ahead and fill in the rest here. Pause the video if you want time. Then I'll go ahead and graph it. All right. There is that V shape. It's opening down this time. That's because of the negative. We'll talk about that more later, but it's still that V shape. All right, the next one, these are exponential. I know that because my exponent is the x. So these two right here are both exponential functions. And you know that because your exponent is the x there. So let me show you how to do this one real quick in the calculator. So 2 to the x, or to the -2, to do that I'm going to use my caret right here, this little arrow under the clear. And then -2, enter, 0.25. I want it as a fraction, so let me show you how to do that. So you're going to go to math. See right, it says fraction. So that's already highlighted there, so I'm just going to push enter and then enter again. So 0.25 is the same as 1/4. Okay, let me show you that one more time. So let's do 2 to the -1. Enter. 0.5. I know that 0.5 is 1/2, but what if you didn't? You could go math, enter, enter. 0.5 is 1/2. All right, you can continue doing that. Go ahead and fill that in for you. Then I'm going to graph it. -2 up just a little bit. -1 up 1/2. 1, 1, 2, 2, 4. It's getting closer and closer to that x-axis, but never quite reaches it. That's called the asymptote right there. All right, go over here. We're gonna plug it in. This is just like this one, so I'll just fill this in for you. Pause the video if you need some time to work on it. And then you would graph it. And then, oh, that's off the graph, so I'm just gonna estimate it. Ta-da. All right, down here it says, look back at the table patterns, or look back at the tables for problems 7 through 12 on this page. Identify any patterns you observe. What patterns do you notice in these tables? And if you want to be an overachiever, tell me what patterns do you notice in the graphs as well. And email me those. What patterns do you see? Let me know. All right. Okay, I also challenge you to do page 4, so let's go over that. All right, so it's writing a linear equation given a table. So moving backwards, we have the numbers. We want to find out what is the equation. So success criteria for this. You're going to look for the patterns. I have it written down here, I'll show you. Okay. Look for the patterns in the chart. So you're going to start with the Y column. What are the patterns you see in the Y column? Put that on the top. Then go to the X. What are the patterns you see in the X? Put that on the bottom. Change of Y over change of X. That gives you your slope, or your M, in the Y equals mx plus b. So step 1, find the slope. Step 2, find the Y-intercept, the B. How do you do that? You look where x is 0. Where x is 0, that's your b. Whatever the y value is, that's your b. Then you plug those two things in. I found the m, the b, plug it in. Y equals mx plus b, or function notation is f of x equals mx plus b. And then finally, if you can't find this pattern in step 1, that means it's nonlinear, and you cannot write a linear equation because it is not linear. All right, let's go through it. Okay, number 14. I'm going to start with the Y column, and I'm looking for patterns here. How is it changing from one number to the next, Well, from 5 to 1, that's adding 6. Same here, 1 to 7, that's adding 6, adding 6, adding 6. Okay, that was consistent. Good, we're on the right track. So if I'm finding the M, my change of Y over change of X, I just found my change of Y is 6. Now I'm going to check my X. Plus 1, plus 1, plus 1, plus 1. It's going up by 1 each time. That's my change of X. Simplifies down to 6. So my slope is 6. Now I'm going to find my Y-intercept, the B, and I'm going to look where X is 0. Here it is. That means my B is -5 there. All right, put it all together. F of X equals mx plus b. Here's your m. Here's your b. Final answer, f of x equals 6x minus 5. Ta-da! There is your linear equation. Okay, next one. Looking for patterns. I'm going to start with my y side. That one is going down by 1, minus 1. Uh-oh. Plus 1, plus 1. Those are not consistent. What does that mean? If you can't find a consistent constant pattern, non-linear. That was easy. All right, next one. Let's look for that pattern. How do I get from 16 to 8? Subtracted 8. 8 to 4, subtracted 4. Boom, I can stop right there. That is not consistent. What does that mean? Non-linear. All right, next one. If I'm going too fast, you can always pause the video, try it on your own, and then just listen to my explanation. That's the best way to do it. Okay, 22 to 13. How do you get there? You subtract 9. And you subtract 9. And you subtract 9. And guess what? You subtract 9. Well, that's promising. That looks like a good start to my slope. -9 on top. Now I'm going to look at the x's, see if I can find a pattern here. How do you get from -4 to -2? Well, you add 2. And you add 2. And you add 2. Oh, look at that. There's my slope, -9 over 2. That's a good sign. Let me find my b. Whoop, there it is. b equals 4. Put it all together, and what have you got? -9 over 2x plus 4. All right, a couple more to do. Let's see what we got for number 18 here. So -1 to 5, that's adding 6. 5 to 8, that's adding 3. I can stop right there. I love it when you get these non-linear ones. All right, next one. 9 to 3, that's subtracting 6. 3 to 2, that's subtracting 2. I can stop right there. Perfect. All right, so let's see. That concludes the lesson for today. So what did we talk about? We talked about the parent functions that you're going to memorize, and you're going to be able to match up the name with the graph. And then we reviewed how to graph using a table. And then finally, we reviewed how to write a linear equation given a table. So see you next time. Until then, have a great day.